Hello guys, my name is Zachariah Shahideen. Today is October 6, 2025, and this is the prelude to the chiral molecule video in which we'll be discussing a compound that we use on a daily basis. Well, I hope not a daily basis, but you know what I mean. So today's molecule, the molecule I decided to choose was 2,4-isobutyl propanoic acid, commonly known as ibuprofen. The functional groups, we have 3 functional groups, 3 of the functional groups being carboxylic acid, an aromatic ring, your benzene ring, and the third is your isobutyl group. Right? Carboxylic acid is acidic, aromatic ring offers hydrophobic interactions, and you have your alkyl chain, your isobutyl group. Chiral center is the methyl group, right? Adjacent to the alpha carbon. Doing our Fisher projection, imagining we're looking top down, we see that we have a carboxylic acid on the top. So we assign that priority group 1, and this is number 2, priority group 2, because carbon versus hydrogen using Kahn-Ingold-Prelog priority rules. And third, so we can trace this out just clockwise, but since we have our H, we know to inverse that, and that would be S. But we're primarily interested in the S configuration because that's what offers the most therapeutic effects for ibuprofen. Fun fact, if you didn't know, some ibuprofens don't work as well as others because they sell it as an racemic mixture instead of an enantiomerically pure S configuration. So R doesn't really work as well. But speaking of enantiomers, we have the R ibuprofen, which is the less active form. S ibuprofen, the mirror image of the R ibuprofen, and the one that is more active. Diastereomers doesn't really apply for this molecule since there's only one stereocenter. Constitutional isomers, we have other propanoic acid derivatives with different connectivity, but that doesn't really apply to ibuprofen. Those would be different drugs. Intended use, I'm sure many of you guys have used this in your life. It's an NSAID, which stands for non-steroidal anti-inflammatory drug. Some of the effects: pain relief, fever reduction. It's an anti-inflammatory, works through decreased prostaglandin synthesis. Works really well for menstruating women. Mechanism, very interesting mechanism. It inhibits the COX-1 and COX-2 enzymes that converts arachidonic acid to prostaglandin H2. This acts as a chemical messenger for pain and inflammation. What ibuprofen does, ibuprofen comes in the middle of this interaction. Not very good marker, but it essentially inhibits this, so you can't convert arachidonic acid to prostaglandin H2, and therefore you get a reduction in pain.